Welcome to lecture 14 of module 3 of this course called Game Theory and Economics. Before we start this lecture, let me just take you through what we have been discussing so far. We have been discussing the topic of what is known as accident laws. So, accident laws is something we have been talking about. Typically, we are going to look at a situation where there are two parties involved. One party will be called an injurer. This is our player 1, and the other is called a victim. This is player 2. Now, typically in a case of accident, what we shall assume is that when the accident is happening, both these parties are involved, and the loss that is occurring due to the accident is falling on this person, the victim, and this law we shall call it as L, capital L. Capital L is either 0 or positive. Now, this is a loss, but behind the loss it is possible that both these parties have been responsible. It may happen that the injurer has been careless in avoiding the accident, that is why the accident happened, or it might be the case that the victim has been careless in avoiding the accident, and that is why the accident has happened. So, this L can be thought of as a function of two variables. This will be called A1 and A2. Now, what kind of function is L of these two variables A1 and A2? It is reasonable to assume that if A1 or A2 go up, that is the players are taking more care in avoiding the accident, then the loss that is suffered by the victim should reasonably go down. It may also be interpreted, this L might also be interpreted in the sense that it is the expected value of the loss. So, it can be imagined in the sense that if more care is taken, then there is less probability for the accident to happen, and if there is less possibility that the accident happens, in that case the expected loss due to accident, that is L, also goes down. So, L can be thought of as a function of A1 and A2, and it is a declining function in both the variables. So, I can write it like this. It is a continuous function, I am going to assume, which means that these two things exist and they are negative. If more care is taken, there is less loss incurred by the victim. So, this is one part, and this is the loss incurred by the victim, and we are going to assume that L, A1, A2 are measured in the same unit. Let us call this maybe money. So, which means that I can add, subtract L with A1 and A2. Now, if there is a loss, then what is the role of law in this case? The role of the law is the following, that law can say that if there is a loss, then the entire loss should not be borne by the victim. The law might say that a part of the loss, a fraction of the loss, has to be borne by the injurer who has caused the accident, which means that there is a fraction of the loss which has to be compensated by the injurer, and let us call that fraction as rho. Now, rho can also be thought of as a function of A1 and A2. So, I can say that rho is a function of A1 and A2. Now, what kind of function this will be? If A1 rises, this means that the injurer is taking more care. In that case, it is reasonable to assume that rho should go down, because he is taking more care. So, he is less responsible for the accident, and therefore, he should bear less fraction of the loss that has to be compensated. So, it may be reasonably assumed that if A1 rises, if A2 rises, what happens? If A2 rises, that means victim is taking more care. If victim is taking more care, it can be safely assumed that he is less responsible for the accident. So, in that case, rho should go up, because rho is the fraction that is compensated by the injurer. So, I can say that it appeals to logic that as A2 rises, that is, if the victim is taking more care, he should be compensated more, because he is not responsible. That is why rho should rise. So, this is the this is the more or less the story. Now, in this story, what is the payoff of the injurer when the accident has happened, and when it has been decided what is the value of rho. So, payoff to player 1, that is injurer, is how much? Remember, he has to take this care of A1, he is taking in fact the care A1. So, minus A1 is the initial payoff, because we are going to assume that when one takes care, it is expensive, it is costly for him to take that care. So, minus of A1 is the payoff because the person is taking care, minus he is going to pay the compensation. So, this is the loss to him due to the fact that he has to pay rho fraction of the loss to the victim. What is the payoff to player 2? He takes a care A2, so minus A2, minus a part of the compensation, a part of the loss will not be covered up by the compensation. That part of the loss he has to bear, and this part of the loss which is not covered by the injurer is 1 minus rho multiplied by L. So, this is the loss due to accident and this is the care that he is taking. So, both are being added up. So, this is the setting. In terms of language of game theory, therefore, it has become very clear what are the parameters of the setting. First, the players. So, A1 and A2 are the cares and these are the actions that are taken by player 1 and player 2. Remember, these actions can be 0 or positive, which means that they cannot be negative. So, if someone is taking a care close to 0, very small amount of care, which basically means that he has been negligent. So, negative does not arise. If I have to show that person has been negligent, I just tell that the A1 is the A that he is taking is very low, close to 0. So, the preferences are represented by payoff functions. So, this is the payoff function of player 1, that is the injurer. Okay. So, this is it. Now, there can be different kinds of laws in the that is enshrined in the legal system of the country. What we are going to look at is a particular kind of law which was in practice in the United States for a long time, and this law is called negligence with contributory negligence. So, what is the idea? The idea is that this law fixes a certain critical level of care, a threshold level of care that has to be undertaken by each of these two players. And if it is found that the injurer has not been careful enough, that is his level of care is below this critical level of care specified by the law, and simultaneously it is the fact that the victim has been careful, that the victim has taken sufficient care which has been specified by the law, only in that case the injurer will pay compensation to the victim. So, there are two conditions that have to be satisfied. First, the injurer has been negligent and the victim has not been negligent. If these two conditions are met, only in that case the injurer will pay compensation to the victim. And the compensation is such that it is the full compensation, which means that the entire loss is then borne by the injurer. So, in that case rho is equal to 1. If any of these two conditions is not satisfied, which means that the injurer has been careful or the victim has been careless. If any of them is satisfied, in that case the injurer does not pay anything, the entire loss is borne by the victim. So, this is what is meant by negligence with contributory negligence. So, the first negligence is the negligence that is caused by the injurer, and the second negligence, contributory negligence. Here we are looking at a negligence by the victim. So, in terms of mathematics symbols, what it means is that rho is equal to 1 if here x1 and x2 are the threshold level of cares that is specified by the law, they are given from outside. These are the parameters, and if this is not satisfied, not this condition, which means this. So, again just to repeat what we have been saying is that if the injurer has been careless, that is A1 is less than some value, and the victim has been careful, that is A2 is equal or more than a particular value, in that case rho is equal to 1, the injurer bears the entire loss. If any of them is not satisfied, if A1 is greater than equal to x1, that is injurer is careful or the victim has been careless, then rho is equal to 0. Now, this may seem a little harsh on the victim, because he is getting compensated only if both these conditions are satisfied, but it is not so. I can play around with x1 and x2 and get different kinds of loss. For example, suppose x1 is greater than 0 and x2 is equal to 0. Now, in this case, if x2 is equal to 0, then what is happening is that this is never satisfied, this condition is never satisfied, this is always satisfied, because if you remember A1 and A2 are positive or 0, they can be either positive or 0. So, this is always satisfied if x2 is equal to 0, which means that whether the injurer will pay something or not now depends on purely on his action. If he is less than x1, if A1 is less than x1, then he pays. If x1 is less than A1, then he does not pay. So, this is the case where the entire onus is right now on the injurer, the amount of care that he takes. So, this is called pure negligence. So, we do not have negligence with contributory negligence, but pure negligence. And one can do another trick, one can say that x1 is infinity, close to infinity, and x2 is equal to 0. And here what is happening is that this is never going to be satisfied, because x1 is infinity. So, you cannot have any care which is equal to infinity. This is not going to be satisfied, and obviously this is not going to be satisfied, none of them is going to be satisfied. So, this condition is automatically satisfied, which means that here whenever the accident occurs, the injurer pays the compensation, entire compensation to the victim. So, this is the case of strict liability. So, one can play around with this threshold levels of x 1 and x 2 and kind of get different kinds of laws which can be thought to be more just to the injurer or to the victim. Now, this is the general setting. Now, the question is what kind of laws that are most efficient for this society, and if certain law is imposed by the government, is that law efficient? I mean, is that law efficient means if some law is imposed by the government, then will the people generate an outcome which outcome is efficient? Because it may happen that the government wants the people to take some actions, but when it sets out the guidelines, people play some game within themselves and the outcome is such that that is not according to the wishes of the government. So, one is what is the specification by the government, which is x 1 and x 2, and what is the outcome of the game which is being played by the players, and these two can be different. In particular, we are going to look at the conditions under which the outcome of the game, that is a Nash equilibrium, is that an efficient outcome for the entire society. So, and our proposition is the following is that if the efficient outcome for the entire society now efficient will be defined in a particular sense that we are going to look at. So, what one is saying is that if player 1 takes the action A 1 star and player 2 takes the action A 2 star, that is best for the society. And if the government then so this is the result or the proposition one is putting forward. So, what is being said is the following: suppose for the society A 1 star and A 2 star is the best possible outcome, and the government knowing that A 1 star and A 2 star are the best if A 1 star and A 2 star are played by player 1 and player 2, that is best for the society, sets x 1, that threshold level of care by player 1 to be equal to A 1 star and threshold level of player by player 2 to be A 2 star. If the government sets these values, then when the players play their games without the intervention, direct intervention of the government, the Nash equilibrium that they generate is in fact A 1 star and A 2 star, which means that the society is reaching an efficient outcome. So, this is what is being proposed. So, what we are going to do now is that we are going to first show that A 1 star and A 2 star is Nash equilibrium, and the second step will be to show that it is unique, it is the only Nash equilibrium. Now, how to show that this is a Nash equilibrium? Now, the method is as we have been doing before, that given A 2 star we are going to prove that A1 star is the best action for player 1, and given A1 star, A2 star is the best action for player 2. If that is shown, then we know that A1 star and A2 star is a Nash equilibrium. Now, to say that A1 star is the best action for player 1, I have to know what is the payoff function of player 1, given that player 2 is taking A2 star action. Now, so player 1, let us look at the game from his point of view. Given player 2 is playing the action A2 star, what is the action, what is the payoff function of player 1? Now, remember, payoff function of player 1 depends upon two things. If player 1 is taking sufficient care, then he does not need to pay anything. And if he does not take the sufficient care, then he is in trouble, because player 1 has been taking the sufficient action that is mentioned by the government, because I know that x1 is equal to A1 star and x2 is equal to A2 star. Here player 2 is taking this action A2 star which is equal to x2. So, it is now entirely upon player 1 what he will do. If he takes any action which is greater than or equal to A1 star, then he does not need to pay anything, because this condition will then be satisfied. If he takes an action less than A1 star, then this becomes operative, and therefore, he will have to pay the entire compensation. So, this is equal to minus A1 minus and is equal to minus A1 if he takes sufficient precaution, sufficient care. So, there are two ranges of value that has to be considered as far as A1 is concerned, and suppose this is A1 and this is U1 and this is the 45-degree line. So, this is minus A1, and suppose here I have A1 star. Okay. Now, if A1 is greater than A1 star, then we are talking about this portion. The payoff function is given by minus A1. In that case, what is the best action for player 1? The best action obviously will be to maximize minus A1, which means that he will choose just A1 star. So, for all right, and this is also true for A1 is equal to A1 star, because in that case also this is operative. Now, the problem is, if A1 is less than A1 star, then I do not have this function anymore. I have this function, and in this function I know that as A1 rises, this as A1 falls, this L thing rises. So, if this L rises, the entire things becomes low, it falls, the U1 falls. In that case, I will like to keep A1 as high as possible, because if A1 is high, then L is low, and so U1 is high. So, the player 1, by going by this L part, will like to keep A1 as high as possible. But if A1 is kept as high as possible, this part becomes very high. That means the negative becomes very low, which means there has to be a balance which has to be looked at. One has to see how much this is, if I keep A1 very high, how much is this benefiting me and how much is this causing me a loss. That has to be looked into. But one has to remember that A2 is equal to A2 star in this case. Now, so for this range, how do I find out at what level of A1 this is going to be maximized? Now, to understand that, let us start from one basic principle, which is that how A1 star is and A2 star is defined. We have said that this is efficient. Now, by that what one meant is that the combined payoff functions of these two players is being maximized at A1 star and A2 star, that is U1 plus U2. And what is the value of U1 plus U2? This is the value of U1 plus U2, the total loss. Part of it will be borne by the injurer, part of it will be borne by the victim, and the cares that have been taken by these two players. Total payoff to both these players, and is maximized at A1 star and A2 star. So, this is the meaning of efficiency one is invoking in this case. Now, if at A1 star and A2 star this is being maximized, what is the inference from that? Which means that I am just putting A2 star is equal to A2, or this is maximized. So, it's better to write it this way: at A1 is equal to A1 star, this is being maximized. I am just subtracting, I am just removing this A2 star point because that is a constant. So, at A1 is equal to A1 star, this function is being maximized, and this function is something which we have seen before. This is the function. So, I have got the result that if I want to maximize this function, what I should set is that I should set A1 is equal to A1 star, which means that the shape of the curves that we have here will be something like this. This is a 45-degree line, and we are talking about this part, and this is the function which is minus A1 minus L A1 A2 star. Therefore, the maximum value that can happen is only at this point, at A1 is equal to A1 star. Okay. Now we have got the complete picture that only at A1 is equal to A1 star the payoff function of player 1 is maximized. So, given A2 is equal to A2 star. What about player 2 from player 2's point of view? Is A2 star the best action for him given player 1 is taking A1 star? Now, the proof here is all like before, that given A1 is equal to A1 star, we are going to show that at A2 is equal to A2 star, the payoff function of player 2 is being maximized. So, what is the payoff function of player 2? Remember, since player 1 is taking A1 star action, which means that this is true. So, player 1 is sufficiently careful. In that case, the compensation that player 2 gets is 0. So, I do not have two ranges like I had for player 1, it will be just minus A2 minus L A1 star and A2, because A1 is equal to A1 star. Now, the demonstration is just as before. So, we know at since at A1 star and A2 star this minus A1 minus A2 minus L of A1 A2 is maximized, it means that this is maximized, that is I am just putting A1 is equal to A1 star, because I know that is the action taken by player 1 and which means that at A2 is equal to A2 star this is also being maximized. So, I am going to remove this constant part. And that is the proof. I mean, what we have found is that this is the payoff function of player 2 and this is maximized at A2 is equal to A2 star. So, if A1 is equal to A1 star, A2 is equal to A2 star is the best action, the optimal action for player 2. Therefore, A1 star, A2 star is a Nash equilibrium. So, we have proved that this is a Nash equilibrium. What is the proof that this equilibrium is unique? Now, to do that, what one needs to do is to just the usual way, we are going to find out the best response functions, and if we have two best response functions which intersect each other at a unique point, at a single point, then we have got the proof that there is a unique Nash equilibrium. So, uniqueness. Now, first again try to find out the best response function of player 1. Now, what is the payoff function of player 1? Let us try to remember that. Player 1 pays compensation, full compensation if he is careless, and player 2 is careful. And he does not pay if he is careful or player 2 is careless. So, now one can now think of different ranges of values for A2, and correspondingly one can take one can talk of different best response functions. So, suppose A2 is greater than A2 star, then what happens? If A2 is greater than A2 star, then I have this case. In that case, if player 1 is taking an action which is less than A1 star, okay, then his payoff function is this. Now, in that case, is it possible that he takes an action greater than A1 star? The answer is no. If he takes an action greater than A1 star, because if he takes action more than A1 star, and in which case the optimal thing for him to do will be to set A1 is equal to minus A1 star. So, he can never set an action which is greater than A1 star. At most it can be A1 star, and it is possible that he takes an action which is less than A1 star. It may happen that if A2 is greater than A2 star, at some value A1 less than A1 star, this function is being maximized. That is possible. But what is being ruled out is that if A2 is greater than A2 star, A1 can be more than A1 star. That is being ruled out. So, if A2 is greater than A2 star, A1 cannot be more than A1 star, because if it is more than A1 star, this becomes operative, in which case player 1 can take the optimal action for player 1 is minus is A1 star. But what we are saying is that it is possible that A1 is less than A1 star, that is entirely possible. So, A1 is less than equal to A1 star. If A2 is equal to A2 star, this is what we have just seen, that if A2 is equal to A2 star, the optimal, this is optimal, the optimal A1 is equal to A1 star, because this is the Nash equilibrium. If A2 is less than A2 star, then what happens? If A2 is less than A2 star, so I have this case. in that case obviously player 1 will take just action which is equal to 0, because at 0 this is being maximized. So, this is very simple. So, we have got our best response function of player 1. For A2 less than A2 star it is 0, for A2 is equal to A2 star it is equal to A1 star. For A2 greater than A2 star, we can say that player 1's optimal action should be either equal to A1 star or less than A1 star, it cannot be more than A1 star. Now, let us look at player 2. Now, to analyze the best response of player 2, first let us gather from the analysis above that A1 never exceeds A1 star. So, the ranges of value that I have to look into for A1 is that it is equal to A1 star or less than A1 star. Now, for A1 star, for A1 is equal to A1 star, the best response I know is A2 star, that is been established, that has been established. So, the only thing I have to look at is that if A1 is less than A1 star, then what happens? What should be the best action of player 2? That one has to look at. Now, for player 2, what is the payoff function of player 2? Payoff function of player 2 is the following, that given A1 is less than A1 star, he will get the compensation. If he gets the compensation, his payoff is minus A2, and this happens if he is careful, that is A2 is less than equal to A2, greater than equal to A2 star. And if he is not careful, he is not going to get any compensation. In that case, his payoff is okay. This is because I know that player 1 has been negligent. So, it entirely depends on player 2 now. If he is careful, then he gets the compensation. If he is not careful, then the second thing becomes operative, that he does not get compensation. Now, what we are going to show now is the following, that A2 star is the best response for, sorry, this is U2. What we are going to show is that A2 star is the best response for player 2 if A1 is less than A1 star. That is what we are going to show. Now, to show that, first let us again remember at A1 star and A2 star, this function is going to be being maximized. Now, if this function is being maximized at these values, that means it is being maximized at the values, this also given A1 is equal to A1 star. I am just taking different values of A2, and I know that at A2 is equal to A2 star, this is being maximized. So, this is being maximized at this value also. Now, I can say from this that I can just forget about this minus A1 star part on both sides. And since this is greater than 0, which means that minus A2 star, so all this will be greater than equal to minus A2 minus L1 star A2. Now remember, the A1s that we are considering are less than A1 star. As A1 is less than A1 star, which means that L A1 A2 is more than L A1 star A2, right. Which means that this, and therefore it means that A1 star is greater than this value, and this is for all A2. So, I have just combined this fact with this fact to get that minus A1 A2, so this will be minus A2 star. Minus A2 star will be greater than equal to this, which means that at A2 star this payoff function is being maximized. This is the payoff function that we are considering. At A2 star this is being maximized. And that is what we wanted to prove, that if player 2 takes the action A2 star, that is the payoff that he gets is higher than any other payoff that he can get given different values of A2. Now, this means that how will the payoff functions, the best response function of A1 and A2 look like? We have seen already that this is player 2's payoff function. Player 2's payoff function I have seen is A2 star, which is constant, and this is A1 star suppose. Up till this we consider, and after that we are not concerned. So, this is player 2's best response function. And what about player 1's best response function? This is what we have seen as the player 1's best response function. It is given by this line 0. This is A2 star. At A2 it is equal to A1 star, and if A2 is greater than A2 star, it can be less than A1 star. Now, if I combine this with this, remember this point is not included, this point is included. if I combine this with this, the only Nash equilibrium, the unique Nash equilibrium is at A1 star and A2 star, because this is the point where the functions are meeting. Otherwise, there is no meeting point, but because this point is not included here. However, this point is included here. After this, it can take any shape, I am not concerned. So, we have proved the uniqueness and the fact that A1 star and A2 star is a Nash equilibrium. So, this is the end of the lecture. We have finished this section of applications of Nash equilibrium. In this particular lecture, we have covered accident loss. In the next lecture, we shall talk about what is known as mixed strategy Nash equilibrium. Thank you. What is the general framework of accident law games? In accident law games, what we have is two players, the injurer and the victim. So, the injurer has caused some injury to the victim, and the loss to the victim due to this accident is given by minus, or if we forget about the minus sign, the loss is given by L of A1 and A2, where A1 and A2, AI is the care taken by player I in avoiding the accident. I could be 1, 2, where 1 is injurer, 2 is the victim. And we can realistically assume that if AI rises, L, the loss will go on declining, okay? Because more care you take to avoid the loss, to avoid the accident, the loss is assumed to, the amount of loss is assumed to fall. We can interpret in another way also, that more care you take to avoid the accident, the probability of accident occurring, that declines, and so the expected loss from the accident, that declines. So, in terms of probability also, this can be, in terms of expected value also, this can be interpreted. So, what is the payoff to player 1, which we write by E1? First, minus A1, remember A1 is the care that she takes in avoiding the accident, and taking care is costly. So, minus A1 minus rho, which is a function of A1 and A2, multiplied by A1 multiplied by L, which is a function of A1 and A2, where rho is the fraction of loss which I bears by law. Similarly, A2 will be, sorry, U2 will be this, that part which is not covered by the injurer, that has to be borne by the victim. So, we have 1 minus rho multiplied by L. So, this is the general framework of accident law games. The law specifies rho. Okay. Rho is specified by the law, and given the different ways in which rho is specified, the players decide how much of care that they will undertake. So, this is essentially the framework of the accident law games. Explain the legal rule known as negligence with contributory negligence. What is the unique equilibrium if social welfare is assumed to be summation of individual payoff functions and welfare maximizing care levels are set as norms. So, negligence with contributory negligence it basically specifies the value of rho, and it is given as the following: rho is equal to 1 if this, where x1 and x2 are the norms by law. So, if the injurer has been negligent and the victim has not been negligent, then the injurer pays the full compensation. Otherwise, in the negative of these cases, the victim bears the complete loss, the injurer does not pay any compensation. Okay. And the last part of the question is that what is the unique equilibrium if social welfare is assumed to be summation of individual payoff functions? So, if social welfare, let us call this S social welfare, is U1 plus U2, then we can see that this is nothing but this, and suppose A1 bar A2 bar maximizes S, then if x1 is equal to A1 bar and x2 is equal to A2 bar, then equilibrium A1 will be equal to A1 bar and equilibrium A2 will be A2 bar. So, that is the result. Thank you.